Hello. Hi, good evening, everyone. Welcome to today's tutorial session. It's 7 o'clock, but I think only four of us are here, so maybe we can wait for another 2, 3 minutes and then start. Okay, so good evening once again. We can start today's session. So, once again, welcome to all. Welcome to today's live session. We will be discussing the topics discussed in this week, that is week 7, module 7. We discussed about landfills, sanitary landfills. All the lectures were about landfills, what are the criteria, uh, starting from the basic composition of elements, what are the layers in the landfill, how do you pile, what are the different methods, how do you calculate the area required for a landfill, the designing of landfill. So we went into all the details of how sanitary landfills are designed and implemented. So let's get started. I hope my screen with presentation is visible, my audio, video, everything is okay. With the confirmation, we can get started today. Yes, no? Confirmation? Anybody? Okay. So as I've been saying for all the weeks, you if you can keep your camera on, it would be really nice. Yes, thank you. Thank you, sir, for that response in the chat box. Thank you. That makes me feel that yes, I am audible and my internet connection is stable. So if you can keep your videos on, it would be great because it's just few of us. So I guess the bandwidth issue will also not be there. And if you can respond to the questions by speaking the answers out, it would be amazing. If not possible, you can put it in the chat box also. Let's make it more interactive. That way it would be better because you've already seen the lectures, you already know most of the answers to the questions that we are discussing. So we are just going through it to get the pattern of how the questions are and so that you can solve your assignment questions easily. Okay, so let's get started. So the first problem, a sanitary landfill should be located at a distance of dash kilometer from airports as per solid waste management rules 2016. Option A, 5. Option B, 20 kilometers. Option C, 30 kilometers. Option D, 40 kilometers. Anybody? Any guesses for this answer? 20 kilo. Somebody has put in the chat box 20 kilometers. Yes, you're right. 20 kilometers is the answer. So this is what we saw in our lecture on different rules or oopsie, yeah, different rules or criteria for site selection as per the rules of 2016. So in that we saw based on where do we locate landfill. So based on the amenities which are there nearby or the land use or land cover which is there nearby, we need to plan the location of the landfill accordingly. So as per this, from sorry, okay, yeah, from airports, the landfill has to be at least 20 kilometers away. There are other aspects also. For instance, if you have a highway, then it needs to be 200 meters from a highway, 100 meters from a river, 200 meters from a pond. We'll have similar questions coming up in this time's assignment, and today also we'll discuss some similar questions which talk about solid waste management rules of 2016. So yes, so that's the correct answer, 20 kilometers. So let's go to the next question. Match the different layers in the final cover of sanitary landfill with their thickness and choose the correct option. So we have different layers in the final cover. We're talking about final cover, not the main landfill, the final top cover of the landfill. So the different types of layers given are barrier soil layer, drainage layer, vegetative layer. And the specification is given in the size 15 centimeter, 45 centimeter, and 60 centimeter. So, yeah. Somebody says option A. Okay. So option A would be barrier is 45 and option A is P is 2. Barrier, okay, as per that, 45 and drainage would be 360 and vegetative would be 15. Okay, anybody, any other answer? Do you want to, somebody, any other answer or difference of opinion? No one? Okay, so let's see these three layers, how they come or what is the order in which the layers are there. So usually we have the waste, which is over here. On top of that, we have the barrier soil because on top of the waste, we have the barrier which protects the waste from the outside. So we have the barrier soil and then we have a small drainage line which goes above through that. So that's the drainage. And then on top of the drainage, we have another layer in which the vegetation is put. So this is how the top layers are designed. So now the barrier soil is usually about 60 centimeters because we need a thick barrier. And then the drainage, you need a very thin drainage line because whatever water comes, it needs to go out, and you don't need a very thick drainage line. So that is usually given as 15 centimeters. And then the vegetative cover is given as 45 centimeters. So that works out to barrier would be, so barrier is the bottom most in the top layer. So that would be 60 centimeters. Then we have drainage layer, which is 15 centimeters. And then we have the vegetative layer, which is 45 centimeters. And that works out to option C. Right. Yes, option C. Okay. So let's proceed on to the next question. Which of the following statements are true in regards to landfill site selection? P. Landfill site can sometimes, landfill site can be sometimes allowed to be located over a fault line. Site sensitivity index helps in determining the suitability of landfill site. R. Average hauling distance is considered in the absence of a detailed plan to understand transportation costs before site selection. S. Sites with higher water tables incur less cost. So let's go to option P. So we've been asked to find what is a true statement in regard to landfill site selection. First one, landfill site can be sometimes be allowed to be located over a fault line. Is that a correct statement? What is a fault line first? Anybody, what do we mean by a fault line? We usually use this in while designing drainage systems, all that. We always talk about fault lines. Okay, so fault line is nothing but on the earth, if there's if you take the literal meaning itself, on the earth there's a fault, or for instance on the surface if there are cracks or some openings or divergence on the earth's surface. So usually volcanoes or eruptions happen in these along these fault lines. So here we are talking about landfill site, and we are so this option says that it can be placed over a fault line, which is a wrong statement. So as per if you we can imagine if we place a landfill site over a fault line, if there is a crack or a disturbance, and if there are some eruptions or if there's some problem, then the whole landfill site would be there would be a disturbance in that whole region. And we know that landfill sites are designed for a longer duration, around 15 years. It needs to be there as such so that the waste can be processed. So this is a wrong statement. Landfill sites can never be placed over a fault line. So sometimes that's a wrong statement. Now let's go to the next one. Site sensitivity index helps in determining the suitability of landfill site. Is that a correct statement? Yes, no? Yes, no? Yes, thank you, sir. Yeah, yes, it is the correct statement. We have been discussing that we use site sensitivity index where we look how sensitive the site is for it to be a landfill site. So we have several parameters that we use in order to find this. We look at there are several. We've discussed a lot of parameters starting from the location, the amount of waste generated in that region, the transportation cost, the environment, the climatic aspects of that region, the water table, where is the water table located, the vegetative cover, which is usually present in the nearby regions, even the adjacent facilities or amenities which are there in the near. So based on all these aspects, we develop a site sensitivity index, which talks about how sensitive the site is to be a landfill site. So if it is highly sensitive or if it has a high sensitivity index, then it is not preferred because it's more sensitive, then it's not preferred to be a landfill site. So sites with low sensitivity index are usually preferred to be preferred to be a landfill site. So this is a correct statement. Now let's move on to R. Average hauling distance is considered in the absence of a detailed plan to understand transportation cost before site selection. That is a correct statement because when we do not have a detailed plan, we need to go for average distances to calculate the transportation cost. And in entire last week's discussion, we discussed about how important transportation cost is to overall solid waste management because based on the primary transportation, the secondary transportation, the vehicles which are used, it increases the cost of whole solid waste management planning. So we take the average distance in order to have our initial estimates. So that's a correct statement. And then we have S, which talks about Sites with higher water tables incur less cost. Is that a correct statement? Yes, no? Anybody? Just anything. Okay, I think Raja says no. Okay, if sites with higher water tables incur less cost is a wrong statement. If that is a wrong statement, then what is the correct statement for that? How do we correct this statement? It incurs more cost. Yeah, two ways. Sites with higher water tables incur more cost, or we cannot choose sites with, is that it incurs more cost. Yes, very good. It incurs more cost. Or we can say that sites with low water tables incur less cost both. So now why this is happening, we have discussed before that if you have a site with a higher water table, which means the water level is much close to uh, the land. So which means if this is a sanitary landfill and if we have the uh, waste deposited in this region, if the water table is very close to this region, it will easily seep in, the leachate will easily seep into the groundwater table and contaminate the water. So we need to provide, I mean, even if you're providing adequate drainage facility, maybe that is not adequate enough in order to prevent this leachate into the groundwater if the water table is high. So in this case, we will have to go for additional sealing methods, like we have learned about creation of certain drains or trams in which we collect this water, collect leachate and then moves away. So we need to go for additional methods. So we have another question on that where we'll discuss this in detail. What are the different methods in order to prevent seepage of water into leachate into the groundwater? So there are additional, so we need, the idea is we need additional methods in order to prevent this. Whereas if the water table was low, then these additional methods that we're using, we'll have adequate space for these additional methods, and we do not need a lot of methods because earth itself acts as a barrier by which which will prevent water from moving down. So the cost incurred in preventing the water from groundwater from being contaminated is much lesser if the water table is low, whereas it is much higher if the water table is high. So because of this, sites with higher water tables incur more cost. So this is a wrong statement. So that works out to Q and R are true statements. So Q and R, so C is the correct answer. Q and R are correct statements. Okay, so let's proceed on to the next question. Yeah, so this is what, before we proceed, this is what we discussed. We discussed about fatal flaws. That is, under these circumstances, we cannot build a sanitary landfill in those regions. So it's called a fatal flaw. And a fault line is considered to be a fatal flaw. Other fatal flaws are slopes or if it is built near a geological feature which compromises structural integrity. Then comes even the groundwater. So based on the groundwater, we have certain distances which needs to be maintained between the groundwater table and the liner so of the landfill. So yes, so those details are given over here. We also have additional rules as per solid waste management rules of 2016. So this briefly we saw in the previous question, we saw this. Now in detail it's given over here. We'll have another question also where we'll look into more details of this. Right. Let's proceed on to the next question. Match the site investigation parameters with its attributes and choose the correct option. The investigation parameters given are subsoil investigation, hydrological investigation, and surface water investigation. And attributes are depth and pressure of water, water balance analysis, availability of soil for liners. So option one, subsoil investigation, uh, which matches. Does it is the attribute about depth and pressure of water, water balance analysis, or availability of soil for liners? Anybody? Okay, so I guess this, by looking at the terminology itself, we can answer this. So we're talking about subsoil investigation. So what happens in the subsoil? When there's a landfill site, and this is the soil. And in the subsoil, we'll have to put some liners so that the contaminants do not move into the ground, into the water. Uh, Sorry, someone wants to join. Yeah. So we need to put these liners. So the subsoil investigation is mainly done in order to see whether we have adequate space available for liners. So this is again linked to the previous discussion which we had about groundwater table being higher. So if the groundwater table is at a higher level, then we will not have adequate space for these liners. So, okay, I guess LA Raja has put option D as the answer. Okay, yes. So, as per option D, yes, P works out to 3. Very good. Now we have hydrological investigation. So, hydrological investigation is done in order to look at the pressure of the water. So, hydrology, we know that we are looking at the water table, the depth analysis, the pressure, and all that. So yes, as per option D, that's the correct statement. The depth and pressure of water. And surface water investigation is done in order to do water balance analysis. Now, what is water balance analysis? Can somebody recollect from our lectures what was water balance analysis? What are we balancing in water balance analysis? I mean, it's definitely water, but what kind of water? Okay, so water balance analysis is mainly done in order to predict how much leachate would be there. Okay, somebody has put pH. No, it is not for pH. It is done in the water balance analysis. Yes, somebody has predicting leachate generation caused by infiltration of precipitation to properly size and design the leachate collection, transmission, and treatment systems. Very good. Absolutely. That's a correct statement. Yes. So what we do in water balance analysis is we need to see how much of leachate would be produced and why leachate would increase because of some surface runoff or precipitation or due to several factors. Uh, so we know that leachate, so what is essentially leachate? If we have some waste, it will have some moisture in it. Now, after some time, this moisture will settle down. And when this moisture settles down, that water which comes, so it'll be in the form of a very black liquid after all the moisture settle down because from all the waste, all the moisture is coming. So this is leachate. And now if we have some other surface sources or precipitation or any other sources which is adding more water onto this existing moisture which is present in this waste, it will increase the leachate which is present. So we design our drainage system for this leachate to pass through so that it doesn't get contaminate the groundwater. So we need to design our systems by calculating this leachate which would be produced. So for this, we need to know what is the surface water which would be added. So this is the water balance analysis that we are doing by predicting how much of leachate would be generated. Very good, absolutely right. Ali Raja has very correctly put it in the chat box. Okay, so this works out to option D. Yes, that has also been correctly answered. So this is what we discussed in our lecture. We have subsoil investigation, groundwater investigation, and surface water investigation. So in our subsoil investigation, so we discussed availability of liners. In addition to that, we also looked at the chemical properties, physical, hydraulical properties of the material and the bedrock, because we need to know what is the composition of these materials, whether it's strong enough to hold, is it a clay soil, is it the physical properties, what are the chemical components which are there. So all this is done in the subsoil investigation. Then in the groundwater hydrological investigation, we look at the baseline of groundwater quality, then the groundwater depth and pressure, soil bedrock condition, groundwater flow, etc. And in the surface water, the drainage plan, water balance, water quality, etc. So this is what we discussed about water balance analysis, where, as very rightly put, it predicts the leachate generation. And that we also discussed about the different models which are used. So these are, there are softwares to do this. There are EPA, water balance method, HELP method. So these are different methods. So the mathematical, we did not go into the details on how these models work, but we know that there are several methods in order to do this water balance analysis and predict the leachate. Right. Let's proceed on to the next question. Problem 5. Match the data categories with respect to the information it provides and choose the correct answer. Categories of data: geological maps, topographic maps, water use plans, groundwater maps, and information, private and public drinking water wells, bedrock wells, depth of water table and flow patterns, indicates low and high areas. So different maps. So we have discussed in our lecture that we need data on a lot of aspects before we plan our landfill site and the transportation, everything. So the different maps are given and the information is given. So let's try to answer this. Geological maps, what would that be most useful for? From the options, so geological, yes, bedrocks, very good. Somebody has put geology is related to bedrocks, so geological is for bedrocks. We also do other geological analysis, the quantity, composition, all that we get them. The composition mainly we get from geological maps. Now here the information given is bedrock, very good. Topography maps, what does it give? Topography map mainly talks about the contours, the heights, the levels, and all that. So that gives us information regarding, very good, low and high. It's rightly put in the chat box. Low and indicates the low and high areas. So it's something like we'll have the topography. So we'll have contours plus zero point 0.5. This is plus zero point 0.2. Then here it's plus zero point 0.1. So you'll have a baseline. So you'll have a contour map. And then based on that, you have a topography which is generated. So if this is the map in plan, in our section, if you take a section like this, in the section it'll be something like this. So this is where our point 0.2 lies. This is where our point 0.5 lies. So yes. Now, water use plans. So that we have discussed. So we have water use plans and we have groundwater maps. So groundwater map is the one which gives, yes, R is 1. Somebody said R is 1. Yes. So groundwater maps gives us a depth of groundwater table, and water use maps gives us the public and private drinking water table. So that works out to option B, is it? P is 2, Q is 4, R is 1, and D is 3. Yeah, option B. Okay, yeah, somebody has already put it in the chat box. Sorry, I just noticed it right now. Yes, option B. Right. Let's proceed on. So these are the different maps that we discussed. So in addition to the maps which we discussed in the options, we have soil maps, which gives us the types of the soil, the agriculture use. Then we have land use maps. Then we have floodplain maps, aerial photographs, the satellite imagery. Then the other data. So these are different map. The other things we can have groundwater maps we discussed. We also look into the data, like for instance, rainfall data, windrows maps. So windrows is something, it's called a rose because it's something like this where we have different directions based on from different directions how much wind is coming. So it's something like this: from the west have this much wind, from the north have this much wind coming. So it gives us both the speed of wind as well as the direction of wind, and that helps in identifying in planning how the landfill needs to be there. So we have wind rose maps, yeah, predominant wind direction and then area. Then we have seismic data and then road maps. So let's proceed on to the next question. Match the operation alternatives of a sanitary landfill with its description and choose the correct answer. So the operation alternatives are area fill method, trench fill method, and modified area fill method. And the description are suitable for areas with low groundwater table. 2, can have large working phase accommodating many vehicles. And 3, allows the best control of litter compared to other fill methods. Yes, so these are the 3 different types of filling of landfills which we have discussed. So their descriptions are given. Uh, yes, anybody? Uh, area fill method, which one? Okay, so before we try attempting this question, let's first look at what is an area fill, like what is the difference between all this. So an area fill, it's something like we have the region. So if this is our ground, this is our ground, we put the waste on top of the ground and then we fill it up like this. And now once this gets filled, then additional another portion is added, another portion is added. Now when this gets filled, we are adding it on top. So something like this. So the idea is it's on top. So you have the ground level and it's filled on top. And so this is area fill method. Then we have the trench fill method, where if this is the ground, we make a trench in the ground. So the ground becomes a trench now, and then we fill this with the waste. So it's a trench. So that is trench fill method. And then we have the modified area fill method, where a small trench is created at this and that is filled. and on top of it, waste is dumped. So again, this can be dumped in multiple compartments, and then on top of it again. So it's both. You have a trench as well as you have an area fill on top. So now let's try to answer this question. So I think Ilayaraja has already put in the chat box that area fill is for large working space for accommodating many vehicles. So yes, so that's a correct statement, because in area fill we know that it's on the ground, and then this slope is also made such a way that sometimes vehicles can go up on the ground and then park over there and then fill the next one, or there is another additional, if the additional slope which is created where the vehicles can go up and then again fill. So this gives a lot of space for vehicles, maneuvering space, and large working space and all that. So this is so that's a correct statement which has been answered. So allows best, sorry, can have large working area for for many vehicles. Now trench fill, what will be? Trench fill allows the best control of litter compared to other things. Very good, yes, because it's a trench. So you're you're putting it down. So you're controlling the litter. So on the surface, you do not see anything much, or huge piles don't come up. So that very good for answering that. So yes, so what am I answering? Yeah, it gives better control of litter compared to other methods, and modified area fill method. It's suitable for areas with low groundwater table. So why it's suitable for areas with low ground? So we discussed when we are making a trench again, or we're going down again, and there's a huge pile of waste which is coming on top of it. So which means there can be seepage of leachate onto the groundwater. So if we have adequate space between the water table and um, the trench, only then can we have space for liners, drainage, and everything. So uh, so yeah, so that works out to option A, is it? Yeah, option, no, not, yeah, option A, option A. Very good. That's been correctly answered. Okay, yeah, so this is the explanation for that. I've already explained, so I'm just putting this in the slide, so later when you're referring to the PPT, you can have a look at it. Now, problem 7. That question was clear, right? I need not go into the explanation. I can just proceed, right? Anybody wants me to explain those slides, you can tell. Okay, so we can proceed. So problem 7, cover material used in the final cover layer of sanitary landfill does not include which of the following? A, soil and inert waste, B, street sweepings, C, hazardous waste, and D, construction and demolition waste. Somebody has put option A. Okay, that was for the previous question. I'm supposing option A was put. For this question, yeah. So the cover material which are used, it does it involve soil and inert waste? Yes, it involves soil, and we can use soil and uh, inert waste on top. Street sweepings are also included. Construction and demolition waste are also included. But hazardous waste is usually not included on the top layer. So because of obvious reasons, if it's hazardous waste, it can create problems later. So the top layer, so mainly it is usually the construction demolition waste which is usually put, but other things like street sweepings and solid and inert waste are also put. Right. So let's proceed on to the next. Yeah. So this is what we discussed. The covers, soil, everything applied through a bulldozer, slide slopes are also covered. Yeah. Then we have daily cover. So daily cover, at the end of every operation, we put around a 10 centimeter thick layer. This is again mostly the construction and demolition waste which goes as daily cover. Then we have intermediate covers and all that. But the whole idea is we never put the hazardous waste as a cover. Problem 8. Match the different processes undertaken in the treatment of leachate with the corresponding method and choose the correct answer. So processes in leachate, there are biological process, chemical processes, and physical process, and method aeration, air stripping, and oxidation. So which is a biological process, which is a, so I think we can, yeah, first one, P, biological process, is aeration a biological process, air stripping, oxidation. Okay, so this one, aeration is said to be a biological process where there's a aeration is given, so it's a biological. We'll see the slides in the next slide, and then we'll go to the explanation. And oxidation is considered to be a chemical process because we are adding oxygen. The chemical properties are changing over there. And air stripping means we are not allowing air. So that's a physical process. So air stripping is a physical process. So that works out to option B, that as rightly answered in the chat box. So the processes are, so this is what we have discussed in our lectures. So there are different biological process which includes aeration, activated sludge, nitrification, and denitrification. So this is done in biological reactors. So these are different processes which are used. And then we have chemical processes which are oxidation and neutralization. And then physical processes comes air stripping, activated absorption, ultrafiltration, etc. And these are leachate treatment processes. Then we have certain other co-treatment processes also, where leachate is in or treated with the sewage itself. So those are in our NPTEL on urban utilities. We have discussed about different municipal sewage treatments also. I guess some of you have attended that course also. So we have discussed that leachate is treated along with this municipal sewage also in certain co-treatment plants also. Right. So let's proceed on to the next question. Problem 9. Leachate collection system stays in operation till dash years after closure. A 25 years, B 10 years, C 5 years, and D 15 years. So the system has to still remain in operation. And now why the system has to still remain in operation? Because even when the site is closed, the leachate would have seeped, the leachate can seep down, or it will be there in the ground. So you need to, that system should be there so that the leachate is collected and it is taken, or in order to ensure that the leachate does not contaminate the groundwater, the system should be in place even when the landfill site is closed. So yes, how many years? So the answer is 15 years. So we need to keep it. So we have discussed that landfill sites usually take around 15 years to mature. So in with all these things put together, even when the landfill site is closed, the leachate collection system stays in operation for 15 years. Right. So this is what, yeah. So the leachate is operated 15 years after closure of the landfill. So which means additional waste is not coming in. So whatever is there, it needs to settle down, and the leachate has to be collected, and the waste is stored, or it's getting treated over there. Right. Let's proceed on to the next question. Groundwater management is the process in groundwater management in the process of sanitary landfill is done through which of the following methods? A. Hydroseeding, B. Terracing, C. Detention basins, and D. Slurry trenches. So in the previous one of the previous questions we discussed about having a high groundwater table, how it influences the cost. So we discussed that you need more expensive methods. So these are some of the methods. Like in this, they're asking what is a method that is usually used in order to prevent the leachate from entering the groundwater table. So it's a groundwater management method which is being asked. Um, Option B, I don't think that's, yeah. So anybody, any answers for this question? Yeah, so groundwater management, among these options, slurry trenches are usually used in order to manage the seepage or in order to manage groundwater. And okay, somebody said B. No, B is terracing. So yes, so terracing is a method by which we manage water, but it is for surface water. It is not to manage seepage of leachate into the groundwater. For that, we need slurry trenches where we have an insulated, what do you say? Using a liner, an insulated drainage system is provided in order to ensure that the ground the waste or the contaminants in the waste does not contaminate groundwater. Terracing is usually done for surface water management, so that a lot of surface water coming due to rainfall or from the nearby water bodies and all that. So all the surface water or surface runoff does not get in, so that the surface runoff does not go into the landfill side, we have terracing, so that the surface water immediately goes into as groundwater. So yeah, slurry trenches are impermeable barriers which are created. Yes, slurry trenches are impermeable barriers which are created. And terracing, hydroseeding, detention bases are all methods of groundwater management. Yes, you're right in that aspect, but it is not for a sanitary landfill. It is done in order to ensure that the surface water goes into the ground, and it improves the groundwater table, or it, what do you say, replenishes the groundwater table inside, groundwater level inside. So, yeah, so slurry trenches is the groundwater management process used in sanitary landfill. Yeah, so this is what we discussed in our lecture also. So these are slurry trenches, grout curtains, sheet pilings, etc. are impermeable barriers which are created. So it's usually in the form of an insulated material, and then you will have a pipe which takes the leachate outside. So you have this barrier adjacent to these pipes. And for surface water, management of surface runoff, we have all this terracing, detention basins, hydroseeding, etc. Right. Let's proceed on to the next question. Problem 11. Choose the correctly arranged sequence from the most preferred to the least preferred solid waste management option according to CPHEEO 2016. So we discussed this question in the last class, the exact same question. Now this is uh, applicable to this lecture or this module also, because we have repeatedly discussed this in this module again. So I've just repeated the question. So uh, I'm sure all of you would be able to answer this question. Which one's the correct answer? Source, option A, very good. Yeah, option A. First, we reduce at the source, then we recycle, composting, and because last week we discussed about composting. So that's why this whole process again had to be discussed. Now, here we are discussing about landfill. So, again, we are discussing this again. So, yes, and waste to energy, and finally comes landfill, because you're just dumping in the landfill. So, whatever that cannot be composed, whichever that cannot be converted to energy, we are depositing them in landfill, and then we are keeping it for around 15 to 20 years. Right. So yes, option A is the correct answer. Problem 13. Which of the following involves improved degradation and stabilization of waste through increasing moisture content? Option A, bioreactor landfills. B, dump sites. C, composting. D, recycling. So we discussed that moisture content in the uh, waste in the landfill, that leads to leachate. So leachate needs to be properly channelized and taken away. Now we are talking about increasing the moisture content, so that we can, to treat the waste, we're increasing the moisture content. Now, in which of the following methods do we use this? So the answer is A, bioreactor landfills. So in bioreactor it is different from the sanitary landfills we usually look. So the process requires more moisture to be added. So by adding more moisture content, we are able to stabilize the waste more. Or the chemical processes which are involved in bioreactor landfills require more water. So the answer to this one is bioreactor landfills. Problem 14. Sanitary landfills has to maintain a distance of dash kilometers from highways. This all of you should be able to answer, because in the beginning of this, the first question we discussed about airports. What is the distance from airports? And then we discussed highways. Very good, L.A. Raja. Yes, it is 200 meters from the highway. So we have already discussed this. Just going back to the same slide, we discussed that it should be at a distance of 200 meters from highways, 200 meters from pond, 100 meters from river, etc. Right. So let's proceed on to the next question. Which of the following statements are true concerning specifications for landfill operation and closure according to Solid Waste Management 2016? So we have discussed some of the rules. Now they're asking which of the following statements are true. First one, A, landfill cell has to be covered at the end of each working day. B, an intermediate cover of 40 to 65 centimeter of soil thickness to be provided, and soil thickness, not soil thickness to be provided. C, a vegetative layer of 45 centimeter has to be provided to support plant growth and to reduce erosion. D, a minimum of 5 centi, minimum of 5 meters below the base of a clay barrier layer from the water table has to be maintained. Okay, I'm just seeing something in the chat box, but in the question it is mentioned 200 kilometer. Oh, okay, okay, okay. Yeah, so there is a in the 200 kilometers from highways. Yeah, so it hmm. Okay, so this one, wait, let me just confirm whether it's a typing mistake because this is the rules. I do not want to. Let me just confirm whether it's a typing mistake here or typing mistake uh, there. It should ideally be meters only. Yeah, it should be meters because logically we ask 200 kilometers is a very, very long distance. So it is definitely not going to be meters. But okay, so this question was there in the previous year's assignment as kilometers itself. So maybe a mistake was done in that assignment. So don't mind. Yeah, it should have been meters. Thanks for pointing that out. I did not notice that. It should be meters itself. Right. So let's go to the next question. Yeah, so this is what we were discussing. Option D, a minimum of 5 meters below the case of clay barrier layer from the water table has to be maintained. So first one, landfill cell has to be covered at the end of each working day. Is that a correct statement? It has to be covered at the end of each working day. So yes, so we discussed, it is a correct statement. We have something called a daily cover, which is usually put at the end of each working day. Now B, an intermediate cover of 40 to 65 centimeter of soil thickness is provided. Is that a correct statement? Yeah, that is also a correct, no, intermediate soil cover of 45 to 6, intermediate, is it 45 to 60 centimeter soil thickness? And then we have a vegetative layer of yeah, so intermediate cover of 45 to 65 centimeter soil thickness, that's also a correct statement. Then we have a vegetative layer. Wait, intermediate. Okay, this one we'll just come back to this 45 to 65. A vegetative layer of 45 centimeter has to be provided to support plant growth and to reduce soil erosion. So this we have already discussed the vegetative about the vegetative layer. Is it yeah, so that is a correct statement. Then we have a minimum of 5 meters below the base of the clay barrier layer from the water table has to be maintained. Is that a correct statement? Is it minimum of 5 meters? Okay, that is a wrong statement over here. It's actually minimum of 2 meters. That's it. You just need to provide minimum of 2 meters. 5, it's not necessary to provide 5 meters. This is also a correct statement. Intermediate cover can be 45 to 65 centimeter soil thickness. So if that's the case, which of the following statements, okay, they are asking which of the two statements, so which means A, B, C are correct statements. Only D is the wrong statement over there. Yeah, correct. Only D is the wrong statement over there. So the mistake is that the bottom liner of the landfill should be only 2 meters above the highest water table. 5 meter is not needed. Somebody said option C. Option C, it is C and D. C, vegetative, that is a correct statement. Of 45 centimeter has to be provided for plant growth to reduce soil erosion. We discussed, we have the barrier layer, which is 60, then drainage, which is 15, and the vegetative layer is 45. So it is a correct statement. Right, let's proceed on to the next statement. Which of the following is not a fatal flaw concerning location criteria for sanitary landfills according to CPHEU 2016? So we discussed there are several fatal flaws, and as per CPHEU, which is not a fatal flaw. So the question specifies which is not a fatal flaw. A, location in a coastal regulation zone. B, 30 meters from lakes. A, 50 meters from a non-meandering water channel, and D, at 800 meters from a railway line. So first one, can it be located in a coastal regulation zone? Is that a fatal flaw? Yeah, okay. So in this question, yes, it is a fatal flaw. We cannot locate the landfill in a coastal regulation zone. Why? Because coastal regulation zones are very close to the coast, so we cannot have the landfill in that region. The soil won't be stable, or there are other aspects which even all the construction activities also are regulated in the coastal regulation zone. So we cannot have a landfill in the coastal regulation zone. So that is a fatal flaw, which means here we have asked which is not a fatal flaw, which means that's not the answer for this question. Then the second one is at 30 meters from lakes. Is that can we have a landfill site located at 30 meters from the lakes? 200 meters from the lakes. Yeah, so we can have a landfill site after 200 meters from the lake. So 30 meters lies within this 200 meters, so we cannot have it over there. So it is a fatal flaw, which means this is not the correct answer. Then option C asks, the landfill site can be located at 50 meters from a non-meandering water channel. So from a non-meandering water channel, what is the minimum distance that has to be left? 30 meters, very good. Yeah, it is 30 meters from a non-meandering water channel, which means 50 meters from a non-meandering, 50 is greater than 30, which means this is not a fatal flaw, which means it can be the answer to this question. And the next one is at 800 meters from a railway line. What's the minimum distance which has to be left from a railway line? It's usually 500 meters is the minimum distance which has to be left from a railway line. So 800 meters is greater than 500 meters, which means this is not a fatal flaw. That means it's possible. So C and D are possible. So that works out to option D, C and D. Right. Let's proceed on to the next question. Excuse me. Yeah, so these are the different fatal flaws which we discussed. So from highway 500 meters, from non-meandering water channel 30 meters, ponds and lakes 200 meters. Right. Let's proceed on to the next question. Which of the following is true concerning landfilling site selection criteria? A. A low sensitivity index value corresponds to a lower impact. B. A lower sensitivity index value corresponds to higher impact. And C. The 32 criteria considered for site sensitivity index are given equal weightages. D. The 32 criteria considered for site sensitivity index are given unequal weightages. Option A and D. Yes, correct. So first one, low sensitivity index, low impact, which means the site will be selected. We already discussed this. That's a correct statement, which means B is a wrong statement. And the second one, they're given equal weightages. No, they're not given equal weightages. They're given unequal weightages based on the priority of different aspect attribute. Different weightages are given. Excuse me. So option A and D are correct statements. We discussed about site sensitivity index, how it is calculated. So we have weightages and then the score for each sensitivity attribute, and based on this we take the summation of these and then we get the site sensitivity index. So we are talking about the weightages, and higher the sensitivity, higher the impact, and we will not select that site for the landfill. These are the different aspects which we have discussed. Problem 18, match the following. The different data given: groundwater maps, rainfall data, windrows maps. We've already discussed a very similar question regarding this, so this can be easily answered right now. I'm not reading the information. We can directly go by matching groundwater maps. Which corresponds to groundwater maps? Indicates the depth to groundwater as well as the regional groundwater flow patterns. Yes, directly. Then rainfall data, precipitation data that are used for designing the amount of possible leachate in cities. And windrows maps indicates the predominant wind direction in the area based on which the location and orientation of landfill footprint has to be decided. So that is option A. Option A, correct. Yes, you have put it on the chat box. Very good. Yeah, option A. We've already discussed this, so I'm just proceeding. Which of the following is true concerning liners in a sanitary landfill? A. must have very low permeability. B, must be extremely permeable. C, liners may be required in very arid regions. D, liners may not be required in areas with heavy rainfall. First one, liners should have very low permeability. What is permeability? Permeability is mm, the ability of a surface or a material to allow water through it, or to permeate, so something goes in. Correct, yeah, allow water to percolate, yeah, in very good, yeah. So should the landfill liner be permeable or not permeable? So that will answer our A and B. So first one, it should have very low permeability, because we do not want water to pass through that. It should have very low permeability. So that is the correct statement. Must be extremely permeable is a wrong statement. Then we have C, liners may not be required in arid regions, in very arid regions, and liners may not be required in regions with heavy rainfall. So this one is okay. That is, uh, maybe liners may not be required in, sorry, liners are definitely required in regions with heavy rainfall, because you do not want water to seep in, whereas in arid regions, because it's already dry, it may not be required in very arid regions. Arid means dry regions. So yes, you have rightly answered in the chat box. A and C is the correct answer. Let's proceed on to the next question. Which of the following are functions of final cover? So we discussed final cover before. We have a barrier layer, we have drainage layer, and then we have the vegetative layer. Now this question is asking, what is the function of this final cover? A, it prevents landfill gases from escaping. B, reduces infiltration of pres precipitation into the refuse. C, resists wind and water erosion. And D, accommodates settlement and is visually pleasing. All of them? Is it? Yeah, because it prevents landfill gases. Yes, reduces infiltration, because your vegetative cover, it reduces the infiltration and precipitation into the refuse. Then we resist wind and water erosion and accommodate settlement and is visually more pleasing. So yes, all of them. Let's proceed on to the next question. Leachate volume is calculated by which of the following methods? A, volume of precipitation plus volume of pore square liquid minus volume lost through evaporation minus volume of water absorbed. Option B, we are adding the volume of water absorbed instead of subtracting it. And in option C, we are subtracting the volume of pore square liquid in addition, and everything else we are subtracting from the volume of total precipitation. And option D, we are adding everything. Which is the correct answer? Option A, very good. Yes. So because precipitation is an addition which is coming, so that adds on to the leachate volume. So that needs to be added. Then volume of pore square liquid, that also needs to be added, because that's a moisture content which is there in the liquid. So in the waste. So that's also added. Then volume lost through evaporation. So that is going away. You don't need it. So that we reduce. So that's subtracted, and the volume which is absorbed by the waste. So again, it's absorbed, so which means it's not coming as leachate, but it's still there in the refuse. It's there in the uh, waste itself. So that also needs to be subtracted. So option A is the correct answer. Let's proceed on to the last question. Landfill capacity involves which of the following? Total volume of waste generated in n years plus total volume of daily cover plus total volume of components of uh, labor and cover systems and minus settlement volume. In option B, we are subtracting the total volume of components and along with subtraction of settlement volume. And in option C, we are subtracting everything from the waste generated. And in option D, we are adding everything up, which is the correct answer over here. Last question. So, any guesses? Any is option okay? I think the option A one, which was put by Raja, was for the previous question. For this question, is it the same answer? Option A itself. Yeah, very good. It is the same. I mean, option A itself is the correct answer here also. So why? Because so the capacity, when we're calculating the capacity, we'll have to look at the waste which is generated plus every day what is the way in n years, because we are calculating, we are having this landfill site for a long duration, right? It's for 20 to 25 years that we're designing a landfill site. The lifetime is 20 to 25 years. So the waste generated for the N years or the total lifespan of the landfill site needs to be considered. Plus, what should be the daily cover, which is so every day, what is the waste which is coming and what is the daily day, so volume of daily cover which is put on top of it, which means that is also going to add on to the total volume. So you have some waste coming, now you're putting the daily cover, then you have another set of waste coming the next day, now you're putting a daily cover. So this one plus the total volume of components of fiber and cover systems, so other cover systems. So for the leachate, we will be having the pipe systems, the liner. So this supposed to be liner, not liber. It's a liner and cover system. So for the different liner systems, what is coming, and then yeah, the different. So now on top of it again we have the barrier layer, all those different layers, so all that minus the settlement volume. Why? Because even though initially you might have a bulk, after some time when the moisture, again we have discussed about moisture going down and leachate coming out of it, so this can be compacted and it can be allowed to settle. So what will be the settlement volume? So this settlement volume, that can be subtracted because you're again getting more volume, or else if you don't do this, then you're over designing your capacity, landfill capacity. So option A is the correct answer, right? So that's all for week 7, module 7. If you have any doubts regarding this week's content, you can ask now. Yeah. Any doubts? Anything? Any observations in this week's content? Any suggestions? Nothing? Okay. I hope all of you have registered for the exam and everything is smooth. Any doubts regarding exam? I think most of it is already cleared. Previous classes, few students had already asked. Okay, so if nothing's there, then we can call it a day and end today's class. Thank you all for joining and thank you very much for being so interactive, especially Ale Raja. Thank you so much because that just kept the class moving. So, see you all next week. We will discuss module 8 next week. Thank you. Okay, somebody has put something in the chat box. You want my contact details? Oh, okay, yeah, I can just give you my email ID. cheslu@kgp.ac.in. Yeah, so I've sent you my email ID. Also, in the discussion forum, uh, yes, Shal, you are a bit late. I'll just come back. Yeah. So in the discussion, if there's something in the discussion forum, you can put and then direct the question to me. I will be getting it. Yeah. Okay. Thank you. Yeah. Yeah, Shal, why you're late for today's class? The class is done, or just 2-3 minutes before the class is over. So we discussed module 7 today. Uh, you can watch the recording. If you have any doubts, you can put it in the discussion forum, or if you have any other doubts in other, you can ask right now. Plus, if there are any doubts regarding this, whatever we discussed in the live session today, you can put in the discussion forum and come and answer. I had a question. Will there be a lot of problem solving sessions in the okay, problems so for the exam in this course, so usually all NPTEL courses have a minimum number like 30% should be problems and all that. There are some rules like that, but in this course we won't be following that. We won't have a lot of numericals if that's what you're asking. There would be very few numericals. I think we discussed about what did we discuss? 2 weeks before we had some numericals which we discussed. That'll be area population projection will not be there. You will not have very difficult like we also discussed incremental increase method. Those won't be there. We discussed salesman traveling salesman problem. Those won't come. So all those difficult numericals which you're discussing in the live session, those will also not be come. Every module had problems except two of them. No, today we do not have. Okay, if there are problems in the assignments, then pay attention. If there are problems in the module and somewhere in the lecture, it's okay because you've not discussed those in the assignment, which means it's not going to come. That's how we usually follow. So today we had some problems in order to calculate the area required for a landfill site. How do we calculate all that and the sensitive index calculation? Those are also there, but we did not do anything in the assignment, so which means that they're not going to come for the exam. So don't worry about it, and I can assure you that the problems which are going to come for the exam are going to be really simple. It's not going to be very complicated, and it will be the same type that we have discussed in class in these live sessions or in your assignment. uh, Nothing new will come, so you don't have to worry about it. It'll majorly be theory only. This course is majorly a theory course. Last week assignment wasn't there, but you said there was. You said there was. Okay, last week assignment wasn't there, but as you said, there was calculations done. Uh, okay, yeah, yeah. I mean, I might be doing some extra calculations also. For instance, traveling salesman was an extra calculation which I discussed in the class because we have a 2 hour class. I thought it would be useful for your future also because it's a classic problem. Traveling salesman is a classic problem, so that's why I discussed. But if it's not there in the assignments, you don't have to worry. As simple as that. Ma'am, can we have previous year question papers? Previous year question papers, okay, that I need to check because I do not have them. NPTEL team might have them. So I don't know whether it's available somewhere in a repository or something that will be available to you, or maybe it's not. But one thing is that some questions which have been asked in the previous years NPTEL questions in other courses also, other NPTEL courses also. If it's related to our topic, I put them in our discussions. So those questions will come. We are discussing them. Apart from that, question paper as such, whether it is available for the learners right now, I'm not sure about that because we do not have public access to that as of now. So I don't know whether that's there. I can check with NPTEL team. You can also post this in a discussion forum because the advantage is that in the discussion forum, NPTEL team, the organizing NPTEL team is also there. So they would be able to answer this question better than me because I'm just part of the course live discussions mainly. I'm not part of the core team who are part of the course content, exam preparation, and all that. Yeah. Yeah, thank you. Thank you for joining. I'll be here for another 5-10 minutes. If some people join and if they want to ask some doubts, I'll be around. Thank you. Thank you. Okay, I think that's it for today. I don't think anybody is going to join. So thank you. Thank you for joining. So I'm ending the meeting right now. Thank you.